let's look at the second way in which you can use lower order information when you're trying to get the counts for a higher order n-gram. And in this case, this thing is called backoff. Backoff is also a little bit blunt, but it's actually used quite often. Okay, so in backoff, what we're going to do is we're going to use the highest order model for which we have counts to give our probabilities. But if we do not have any counts, then we back off to the model that's lower. So in our Scottish beer drinkers example, we will use the highest order model that we have. Okay, but if the model has never seen Scottish beer drinkers, then it says, now I'm backing off to the bigram model. Okay, and if it's never seen beer drinkers, then it backs off even lower down, and it backs off just to drinkers. And that's the idea behind backoff. You explicitly say, I don't have counts, I don't have enough counts, I'm ignoring this model, I'm going down to the one that's below it. So it's actually quite simple. If I have a backoff model here, and this is for a general n-gram case, okay? So here we've got the n-1 preceding words, okay? And we're trying to get the probability for the next word. Then if I have counts for this sequence here, if I have enough counts, so counts more than 0, then I just use my n-gram model as I would always, okay? With one little caveat here, which is that little d, which I'll say something about in a second, okay? If not, then what I do is I back off to the lower order model here, okay? So Scottish beer drinkers, oh, I don't have enough counts for Scottish beer drinkers, so I back off to beer drinkers. Okay, and then I use that one. Looks simple, works well, but there are some other math on this slide, right? There's this little d and there's this little alpha, so what the fudge are those? Now remember, every time you do something a little bit weird with probabilities, you need to make sure what? That it sums to 1. If you're doing this and you're saying this thing never occurs, I'm backing off here, you actually need to have some mass in order to use for that back off step, okay? And that is where this little d comes in. So back off is always coupled with add alpha or discounting approach, where you discount the probabilities from the higher order models, and that gives you some mass. And that mass you then spread off to the lower order models. And the way that you spread it off is actually dependent on the specific context. So these alphas here, this is a little factor that you multiply before, for example, you're using your bigram, and that makes sure that the probabilities all sum to 1. Sorry, just again, Scottish beer drinkers. Scottish beer drinkers, now that doesn't work, so I'm going to back off to beer drinkers. But I'm going to have to multiply that with a factor that depends on Scottish beer drinkers, okay, in order for this to still be a valid probability distribution, okay. Now these alphas are horrendous, okay. They're not difficult, it's not slow to calculate them, just the math in order to figure out what the alpha should be is somewhat involved. And you can look in Jarofsky and Martin's second edition where they actually explain how to get these alphas. They didn't bother in the third edition because I think maybe Dan Jarofsky got frustrated and it was too tricky to teach how to do it. Okay, so in the third edition they just said, yes, okay, go on with life. You can also combine, so you specifically need like absolute discounting here, but you can also use additive smoothing techniques, and then the alphas get even more complicated. Okay, and that isn't covered in Jarofsky and Martin's second edition either, okay? But they did cover it in the first edition. So it's a little bit funny if you go through the book sequence, then you can see like how the way people teach changes over time, okay? But so you can go and look at the first edition if you want to use this with additive smoothing. If you're just going to use absolute discounting, then you can look in the second edition. What I want you to know is just the basic intuition. That's what I want you to take away from this. Is everyone happy?